can you just explain, why this facility is so fantastic?
Okay, thanks, Jimmy, and it's a real pleasure to be here with everyone today. I think the best thing is to show everyone and explain how we start from a very small, and I say small, 9 microns actually, which is tiny, you can't even see it without a microscope, how we develop the strain to naturally develop it to give all the nutrition that is actually encompassed in all of the Zealous product. And unfortunately, one of the things that you can't do is actually rely on the ambient, and as you've mentioned, Jimmy, quite correctly, that the climate and the change in climate has caused major issues. It will continue to be a major issue, as well as contamination. So the idea was to house the technology in its own environment, keeping everything as natural as possible, but also allowing and giving us a technology which is always constantly evolving, a technology that allows to get more out of the algae, i.e. more of the nutritional benefit, which obviously fits different and various products within Zealous. So I'm just going to show you very quickly what the algae should look like, uncontaminated. So just bear with me a second. I'm just going to turn this around if I can. So here we see Spirulina Maxima. Now, Spirulina Maxima is this strain. This is 100 times magnification. And you can see the spirulina grown in a set environment, completely controlled. You can see that the cells here are completely full. There's no contamination in this whatsoever. What you will notice is there's a yellow band down here. This is mainly made up of beta carotene, and you've got all the pigmentations here, which is the blue pigment, which is the that wonderful blue protein, which is obviously in a lot of Zealous products. So how do we get that? How do we make this better? Well, I'll just come back. I'll take you over, and please let me know if I cut off, because I'm in the lab, so there may be weak signal. But basically, everything starts life from here. So I don't know if you can see that, but that is the evolution, effectively, of A3 nat from a standard spirulina. And what do I mean by evolution? It means we took a standard spirulina, we built the technology, we made the technology fit around getting the goodness out of the spirulina strain, and therefore a combination of research and development over a number of a further 2 years after the first 7, and still continuing today, allows us to create bigger and better spirulina in its most natural form, i.e. an A3 nat formula. Once you comes out of the of that small state, we call that the mother strain, after a lot of hard work. We then start to scale it. Now, I might cut off in here, but we'll try to do our best. Keep it going.
Tino, we lose you. I mean,
to start off with, really.
Yeah.
So in there, we take those strains that you saw in those scale it up. Once it's scaled, and scaling from microns to approximately 120 liters full of algae, and it's grown under conditions that we set to either get maximum protein, maximum iron, maximum beta carotene, whatever is the downstream application, will then get scaled up into the facility. So without further ado, we'll just change this. So here we are in the facility. The scaling, they look like Daleks, but everything is computerized. There isn't any way to grow algae correctly unless it's computerized. So the algae you saw in the clean room will be housed in these. These are 1,200 liters. It scales up, and the computer system here will actually allow it to scale up and keep everything normal as far as where the algae is come from and where it will eventually go to, i.e. the ultimate product. So based on that, everything stays the same. There's no variation. So because it's indoors and it's computer controlled, then basically we have a stable algae that is grown from start to finish without any form of issue regarding ambient temperature, sunlight, etc., which is detrimental. So once it's scaled, we come over to the bioreactor system. This bioreactor system is literally half as long as a football pitch, I guess, for the best word to give a measurement. But it's under 3 levels, and each level is growing a slightly different combination to ultimately end up at the end. And why we say that is for the same reason as what I'm going to show you. If you look here, the algae starts very transparent. You can actually see the light through it. It's growing, it's happy. When it gets to its second stage, i.e. it's growing, eventually it becomes a dark green. And from that dark green, it means that it's ready to be extracted. And I'll show you some extraction later on. However, there is a second pass which allows us to grow the particular pigment, the protein itself, which is the real goodness inside the particular strain, or one of them anyway. So instead of using white light that you saw over on this side, as you can see, we have red blue lights. Now the red and blue lights is basically will go into this bioreactor. This bioreactor is now ready to take this for Monday, and therefore this is the bioreactor section that actually grows all of the goodness that's inside that cell, basically. So it's a 2-step process, but it's continuous. It never ever stops. How do you do this? Well, like I said, a human can't grow algae as efficient as a computer. If you have to measure 400 times a second what the algae needs, when it needs it, when does it need to feed, is the temperature okay, does it have enough CO2? Well, one thing that climate change has done for us actually is a favor, and that is we have a lot more CO2 in our air, so we pump more air in, we get the CO2, so we're doing our bit for the environment as well, and sequestrating the CO2. So all of the good stuff is being made in those bioreactors. Now to control it, like I said, human can't control it. So what do? We develop the system where it could be monitored anywhere in the world, fully computerized. And you can see these graphs here. Now these graphs, basically, you can see that they're completely flat lines. Why are they flat lines? Because everything is completely stable, and therefore there's no variation. Therefore it's growing at a similar rate than it was growing yesterday, the day before, etc. It's something that you can't do outside, for sure. You'll notice here, there is a dissolved oxygen. Now, one thing is that algae, through photosynthesis basically will take in CO2, will split the CO, will take the carbon to build more algae, i.e. more biomass, and it will expel the oxygen, so it gives us good, clean air, basically. However, when you put the system in darkness, or as it were outside, you would have day and night cycles. And therefore, if you're growing the algae in a night cycle, guess what? It then expels CO2. So you're losing biomass, basically. So the idea of the system was, it was intended to grow with no variation. So you get exactly the same out, day on, month in, year in, out, of the same quality biomass. And more importantly, fixed with the most, packed with the most nutrients that the algae can get in it, because there's only a limitation on the cell size. So part of the research and development, guys, is based on how do we get more into that cell? Well, we can change nutrients. Phosphorus is one of them. The phosphorus allows to grow bigger cells and hardier cells, and therefore allows us to pack more nutrients in that cell itself. So based on that, it's a system that is completely clean. The water is physically made here. It comes from the mountain, spring water. Obviously, it has to be chlorinated by the state to be used. We dechlorinate that water. We put it through a reverse osmosis. So the water, when it comes out of reverse osmosis, is completely particle-free. It is the purest water, literally, on the planet. So the algae is growing in that pure water. It's got no heavy metals. There's no particles. There's no sand particles, no salts. It's a clean, pure water. So the algae's got the best possible start. And one of the things that's very important is that there are no influences here with any, light day cycle, any cycle with regards to, cycle of months. Most times that you can only grow in the hot summer months. but certainly from our point of view, we can grow all year round. And like I said, it is the highest and best quality. So I've got something to show you on the process. Basically, everything is non-mechanical, and it's very important that you have non-mechanical. Why? So that you keep all of the cell intact, including all the protein, beta carotenes, vitamins, all intact inside that cell. So here we have a paste. This is a paste, just to smear it on the page here. That paste naturally comes out, not under pressure, not being pumped. It naturally comes out under its own weight from each level of the bioreactor. So it starts life as a paste, and that paste can be frozen or it can be processed immediately. And what you end up with is you end up with a biomass, basically, in a very crude form. That biomass here has all of the goodness inside those cells. And what happens is we can then take those cells, mill in such a way where they're actually not milled, they're sieved, so that you get a complete powder format. And from that powder format, we can then, using natural process, which is just basically water, allow us to come out and get the raw blue protein. So the protein, the biomass, and the paste, where it starts life, that's directly after it comes out the bioreactor. There's absolutely no mechanical process, no heat process, and therefore, based on that, how would you grow that in sunlight? You can't. And that's why there's a big difference between the A3 NAT formula, Zealous' products at the end of the day, and what is being sent to the shelves, which are in various different places of the world, Spirulina, and you would not get this particular roadmap. You can't achieve that if you grow that outside effectively. So